Good morning to all. Today we are going to see about the observation of the VI characteristics of a PN junction diode. Or aim to study the PN junction diode characteristics under only the forward bias conditions. So we need the apparatus as the PN junction diode, power supply, ammeter and voltmeter. Now we can see the circuit connection. Now we are seeing the circuit connection. So the positive terminal of the battery which is connected to the diode positive, the diode negative is connected to ammeter positive, ammeter connected negative is connected to the voltmeter negative, and voltmeter negative is connected to the battery negative. So how the PN junction diode is working? So here we have taken a p-type semiconductor and n-type semiconductor. Both will be sandwiched, and which is connected, the diode which is connected to the positive terminal, p-type is connected to positive terminal of battery, n-type is connected to negative terminal of battery. When battery is switched on, so the positive charges and the negative charges, here the recombination will take place. So here the depletion layer will produce. When I supply a large amount of voltage, then only the positive charges will break the depletion layer and go to the negative electrons. It recombine with the negative electrons and the current will flow through the circuit. So this is the model graph of the PN junction diode forward bias, that is a volt versus the current. When the voltage is increased, so on particular voltage the current will flow through the circuit. So that will be shown in the means of a table. We are taking values and we will plot the model graph. So when battery is switched on, so here we are having a voltmeter V and then a microammeter. Microammeter here, this is a diode. So this is a positive terminal of the battery. This dome shape is a negative terminal of the diode. This is a positive terminal of the diode and this is the negative terminal of the diode. So when you see the circuit, so here the positive terminal of the battery is connected to the diode positive. So positive terminal of the battery is connected to the voltmeter positive and also the diode positive. So the diode is negative is connected to the ammeter positive. So diode negative is connected to the ammeter positive. So ammeter negative and voltmeter negative, and which is connected to the battery negative. So now we are changing the voltages from 0 to 0.1. So if you see here 0.1, there will be current will be 0. So 0.2, the current will be 0, and then 0.3 also the current will be 0, and 0.4, so the current is increased to 2. So the current is increased to 2. If you see 0.4, it will be tabulator. In tabulation it shows it will be a 2, and then 0.5. So 0.5, it should be 24. So and then 0.6. So 0.6, it will be around 52, and then 0.7. 0.7, it will be around 80, 60s. So like that the current will be increased. For the different voltages we get the current in the tabulation. So we should plot a graph for this tabulation. Here along the x-axis we are having a V volt, and then along the y-axis we are having the I, which should be a milliampere. Here we have taken a 0.1, 0.2, 0.3, 0.4, 0.6, 0.7, like it goes on. And then in the y-axis it should be 5, 10, 15, 20, 25, 30, like that. So for the 0.1 and 0.2 and 0.3, it will be a 0, and at 0.4 it will be increased to 2. Okay, it will be plotted as 2. For 0.5 it should be 24, it will be increased. So along a particular voltage the depletion layer will be broken, and then the positive charges go to the negative charges and the current will flows on the circuit. So this is the IV characteristics for the forward bias PN junction diode. Thank you.